So for day 1 of chapter 11, we are going to talk about our first conic. And what a conic is a blanket umbrella term for specific types of graphs. And the 3 major types of graphs and functions we're going to talk about, or graphs and relations we're going to talk about, are parabolas, ellipses, and hyperbolas. So we are going to approach parabola from a slightly different perspective, a little bit more mathematical definition of what a parabola is, because in your mathematics career up to this point you've seen parabolas quite a bit. You've used them to maybe model some motion, you've graphed them from a few different forms, but we are going to look at parabolas from definitely a slightly different approach and a different equation. So first I'm going to read the definition of a parabola and kind of explain what that means, because this is the true mathematical definition of what a parabola is. So it's the set of all points in a plane equidistant from a particular line called the directrix and a particular point called the focus. So what that means is if we had a specific point called the focus and a specific line called the directrix, and I found a point that was the same distance from that point and that line, and I plotted it, if I continued to do that, picked infinitely many points that are the same distance from a fixed point and a fixed line, it would create the shape of a parabola. And verbally that maybe doesn't help. So what I like to do is maybe just sketch a quick picture. So this is a parabola. This is a parabola that we're used to talking about. We can identify the vertex. We could say it opens upward. We could say it's U-shaped. All that stuff we've used to describe parabolas up to this point. But here's what I want to kind of translate the definition. So here's a parabola that opens upward. Vertex is at 0, 0. And if I were to pick a point here called the focus is a specific distance from the vertex. That distance we usually refer to as our p-value. And you'll see where that p-value comes from when we look at the equations. So this is that point that the definition is referring to. And then if I go that same distance away from the vertex in the other direction, p, whatever that p-value is, and draw a horizontal line there, that line would be my directrix. So the directrix and the focus are always the same distance from the vertex, and here's where that equidistant portion comes into play. So, before we talk about that, there is one other thing that will be new, and that would be what we call the focal width. And the focal width really is a number that just tells us how wide the parabola is at the location of the focus. So again, because I put my focus right there on the y-axis, the focal width would be whatever number that tells me how total wide that parabola is through that focus point. So here's where that equidistant part comes into play. So let's say I picked this point right here on the parabola, so just to the left of the y-axis, and pick that point. That point should be the same distance from the focus as it is from the directrix. So if I picked any point on this parabola and drew a dotted line representing the distance to the focus and to the directrix, it should be the exact same distance. That's what truly creates the shape of this parabola. This U-shaped graph is really that way because of the distance all the points on the parabola are from our focus and our directrix. We're going to look at how to identify all the information we need to graph parabolas in this new context, but I just wanted to give you a visual for the exact definition of a parabola. That same definition holds for a parabola that doesn't open up and down. We could actually have parabolas that open, left or right, sideways. So I'm going to draw one here. Again, I just drew another example of picking another point on the parabola, drawing the distance from the focus and the directrix. Should be exactly the same. Again, that's what makes this U shape. So let's say I put a vertex here and draw one that opens to the right. The focus in this case would be somewhere here. And again, the focus is in line with the vertex, and it is always actually in what I like to call inside the parabola. So if the parabola opens right, the focus should be to the right of the vertex. If the parabola opens up, like the first example I drew, the focus should be above the vertex, and that's always true. So again, the distance. So before we get started looking at specific equations, we want to get some standard definitions down. So let's say we had a parabola that had the vertex somewhere else, some other coordinate h comma k, and that hk should look familiar. We've seen those before when we looked at vertex form of a parabola. This is going to be a different form, but hk is kind of a standard way to describe a point that's not 0, 0. So if I had a vertex at hk, the standard equation for a parabola could be either x minus h quantity squared equals, and then this is where that p value comes in, 4p times the quantity y minus k. So in our specific examples, it won't say 4p, it'll be a number like 10 or 12 or 2 or some number in front of a variable. But again, the way we will find p will be relating that number to 4p. And it'll make sense in a second. So we could have x minus h quantity squared equals 4p times y minus k, or y minus k quantity squared equals 4p times x minus h. And the major difference that I like to look at between them is the variable or the quantity that's being squared basically should tell you which direction the parabola is going to open. So if it's x minus h quantity squared, it's either going to open up if the number in front of my y quantity or y variable is positive, so in this case if p is greater than 0, or it's going to open down if p is less than 0. So if the x variable or quantity with the x in it is being squared, it's going to open up or down, and that will depend on our p value. And then if the y quantity or y variable is being squared, it'll open right or left depending on if the p value is positive or negative. So the parabola will open to the right if p is greater than 0, and it'll open to the left if p is less than 0. And then the other measurement we will need to find, we're going to use p to find the focus and the directrix, but we'll need to know how wide the parabola is, which is called our focal width, and that will always be the absolute value of 4p. So for the first example here, we're given an equation, and we're told it's a parabola, and I'll explain kind of how we recognize that. And we're asked to find the vertex, the focus, the directrix, and the focal width. So the first thing I like to decide is where's the vertex of this parabola is going to be. And the way I know it's a parabola for sure is only one of my two variables is being squared. It's y squared equals something x. It could be x squared equals something y, but that's the first clue that we're dealing with a parabola. Only one of our variables is being squared. So I know that it's a parabola, and then the vertex, because my y variable is not being changed at all, it's not y plus 2 quantity squared or y minus 1 quantity squared, it's just y squared, which tells me the y coordinate of my vertex is 0, and same for x. X is not being changed in terms of shifted left or right, there's nothing being added or subtracted to x, so my vertex is going to be 0, 0. And then, the way I determine the direction it's going to open, that's what I would do next, is if y is being squared, it's going to open left or right, and then that number in front of x, negative 8, is going to tell me right or left. So because that's a negative number, that would mean my p-value is going to be negative, therefore this graph is going to open to the left. So I know where the vertex is and the direction it opens, so it might be a good idea to then find our p-value. So the way you find your p-value is you take the number in front of x in this case and set it equal to 4p, so 4p equals negative 8. It tells me that my p-value will be negative 2. And I will use that p-value, because again that represents distance from the vertex to the focus and vertex to the directrix, to graph that information. So I'm going to put my vertex on the graph, 0, 0, and then what I like to do is go 2 units, again it's going to open left and right, so go 2 units to the left and put a dot, and 2 units to the right of the vertex and put a dot. And then all I need to really figure out is which one's the focus and which one will be on the directrix. So again, because this is going to open left, that means the negative 2, 0 point, and we'll identify the coordinates there here in a second, is the focus, and the 2 units to the right of the vertex will be on the directrix, which in this case would be a vertical line. So that's how I use my p-value, is from my vertex I go p units to the focus and p units to the directrix in whatever direction this graph is going to go. So now I have that, I just want to identify the actual information. So because the focus is a point, we want to say the coordinates of the focus are negative 2, 0. And because the directrix is a line, we want to say the directrix is an equation, x equals 2. If you neglect the x equals or y equals, depending on the problem, then you're not telling the equation of a line, which is not the directrix, and you will not get that correct. So please be sure, especially now at the beginning, be careful with your notation. If it's a line, say it's a line. If it's a point, use notation that represents a point. So now I have my focus and my directrix. All I need to do now is figure out how wide this parabola is and then draw a curve or U-shape that fits the data. So in this case, the focal width, again, is always absolute value of 4p. And because 4p is equal to -8, the absolute value of -8 is 8. So what that tells me is this graph is going to be 8 units wide through the focus. So what I do here is go to the focus and go up 4 units, and then go to the focus and go down 4 units, and my parabola should go through those 2 points that I just sketched and the vertex. And obviously the check here is the vertex 0, 0? Yes. Is the total width of the parabola at the height of the focus or at the location of the focus 8? Yes. And then is the distance from the focus to the vertex and from the vertex to the directrix 2, which in this case it is. So that's the way we sketch parabolas as a conic. We need to find these other pieces of information and then put that all down into our graph. And be specific about the locations and be careful with the way you calculate this. And you should be able to do this no problem. This one, vertex was 0, 0, so we didn't really have to account for any other location, but we will within the next few examples. So for the next example, we're going to try a similar problem. So in this case, we have x squared equals -4y. Again, that's a parabola because only one of my variables is being squared, and because x and y are not being shifted left or right, nothing's being added or subtracted to my x or y variables, I can say the vertex is going to be 0, 0. And then because the x variable is being squared, it's either going to open up or down. And because the number in front of my y is a negative, this graph is going to open down. So I'm going to get that information directly from the equation. And then you can either find your p-value, or what I like to do at this point is actually plot my vertex and just kind of graph as I go, so I kind of get all the information down without having to go back and reread it or redo it. So vertex at 0, 0. Now I'm going to find my p-value. The way I do that is set 4p equal to the number in front of my y variable, the non-squared variable. So what I would get is p equals -1. So because this graph is going to open down, what I like to do then is count 1 unit above and 1 unit below my vertex. And the point 1 unit below my vertex is going to be my focus, since my focus is always inside my parabola. So if it opens down, my focus is down. If it opens left, my focus is left of my vertex. And then 1 unit above my vertex should be my directrix. So the distance from vertex to both of those should be 1, which in this case it is, shown in the graph there. So now I'm going to just identify the coordinates and the equation for the directrix. So the coordinate of the focus is 0, -1, that's that point. And then the directrix should be the line y equals 1. So please be careful that you put your focus as a coordinate and your directrix as a line. So now I need to find my focal width, or how wide the parabola is at the focus, and then I should have enough to sketch this. So the focal width will be the absolute value of -4, which is 4. So that tells me at my focus, the parabola is going to be 2 units to the right and 2 units to the left, which would make a total width of 4. And then you should be able to sketch your parabola that matches that and fits that information. For example 2, we're going to find the same information and graph a parabola, but this equation looks slightly different. So what we have is the quantity x plus 4 squared equals 6 times the quantity y plus 1. So I'm going to find my vertex first, and the vertex will follow the same function transformation rules that we've been dealing with all year, and that is x plus 4 quantity squared is really going to have an x value of -4, and y plus 1 will be a y value of -1. So my vertex is going to be -4, -1, and then because my x quantity is being squared, this tells me it's going to open up or down, and because the number in front of my y quantity is positive, it's going to open up. So that's the information you should definitely want to identify first, because that tells you which direction your focus is and your directrix is from your vertex. So at this point, I'm going to sketch my vertex, -4, -1, and then find my p-value. So 4p equals 6, which means p is going to be 3/2 or 1.5. So then that means, because this parabola is going to open up or down, I'm going to go above and below my vertex by 1.5 units. I'm going to put a dot at each of those spots, and then I have to identify which one's the focus, which one's the directrix. And because this graph is going to open up, the point above, slightly above the x-axis, which is at -4, +0.5, is going to be my focus. So -4, +0.5, and that just came from me adding 1.5 to the y value, -1. And then the directrix is going to be the line y equals -2.5, which is 1.5 units below my vertex. And then the last thing I'll need to find is how wide this graph is at the focus, which is going to be the absolute value of 6, which is 6. So the way I graph that is a total width of 6 means 3 units on either side of the focus, and then draw a parabola that passes through the vertex and the 2 points on either side of the focus that give me a total width of 6. So this would be an example where the vertex is moved, but the same properties apply, in that the distance from the vertex to the focus and the vertex to the directrix are p-value, focal width, all of those things will still apply. So you have to really be able to look at the equation and determine how to find those pieces of information. For the next example, we are going to look at graphing a parabola. In this case, we have our y quantity being squared, which tells me this graph is going to open left or right. And because there's a negative out front of my x quantity, it's going to open left. And then the vertex in this case is going to be 2, -3. Again, it's x minus 2, which is an x coordinate of +2, and y plus 3 will give me a y coordinate of -3. So I'm going to plot my vertex, and I know this is going to open left, so that's going to affect where I put my focus and directrix. So the next thing I need to do is find my p-value, which will then tell me where or how far my directrix and focus are from that point that I plotted for the vertex. So set 4p equal to -16. P is going to be -4. So then what I like to do here is go to my vertex and go 4 units to the left and 4 units to the right. And I know to go left and right because I identified at the very beginning that this parabola is going to open left. So then I should know, if this opens left, which one is my focus. My focus is going to be that point there at -2, -3, and the directrix is going to be that vertical line 4 units to the right of the vertex. So then the focus in terms of the coordinates would be -2, -3, and the directrix in terms of its equation should be the vertical line, x equals +6. So the last thing I need to do is find the focal width, and then I should have enough information to sketch this graph. And the focal width in this case is going to be the absolute value of -16, which is +16. So the way I graph that is I go to my focus and go 8 units up and 8 units down from there, plot a point. So my parabola should pass through my vertex and through my 2 points above and below my focus, which would give me a total width of 16 for this graph. So your parabola should look something like this. And for example 3, we're just matching. So looking at equations and matching which graph fits or makes the most sense. The one thing is there's a small typo in the equation for number 4. That should be y squared equals 7x. Otherwise it wouldn't be a parabola. But so we got to match them. So what I'm looking at is which variable is being squared, tells me whether it opens left or right, and whether the number in front of my other variable is positive or negative. So for number 1, x is being squared, it tells me up or down. And because there's a -5 in front of y, that one's going to open down. So that should be graph B. And then for number 2, I have x squared again, so it's going to, it's going to be up or down. The graph's going to open up or down, and then because that number is 2, is a positive number in front of my y, it'll open up, which tells me that's going to be graph A. And then for 3, y squared tells me left to right, and then that negative 3 tells me the graph's going to open to the left, so that's C. And by process of elimination, or because y being squared and the number in front of x is positive 7, it's going to open to the right. Number 4 should be D. So that's the process of graphing parabolas from a conic perspective, which is identifying what the focus and directrix are and using those numbers to calculate the focal width and sketch the graph that way. Obviously, we could take an equation like the one in example 2b, the one we just did, and plug in a bunch of numbers for x and y, and you would get the exact same shape. But in terms of how we're going to approach this for this chapter is we're going to be looking at focus, directrix, and a lot of these terminologies will definitely be very important as we move further into this chapter when we talk about ellipses and hyperbolas share some of the same properties.